Hey boys and girls, this week we are going to start talking about forces like mass, weight, friction, and gravity. We are probably going to work on this for the next 2 weeks. So we're going to start today going through a couple of PowerPoints. There's a lot of information, but like I said, we're going to continue to practice this for the next 2 weeks. And you can always come back to this PowerPoint and review. Okay, so first, we're going to talk about forces. A force. So a force is a push or a pull. Okay, so you can see that in the picture. The force that's being put on that box is a push. Okay, he could also be pulling that, and that's another example of a force. Okay, forces are measured in newtons. Okay, so we see it sometimes just as the letter N. So that's how much force there is. And also we see the arrows telling which direction that force is moving. All right, so first we're going to talk about balanced forces. There are balanced forces, and those are ones that don't change motion. So they kind of cancel each other out. Okay, so you see the people doing tug of war. They have 3 people on one side, 3 people on the other. They must be exerting the same amount of force because they're not moving. You've probably played tug of war and you've seen that happen. Usually after a while one force outweighs the other, but you've probably had a time where you were just kind of standing still, and that's a balanced force. Okay, also in our picture we can see that the force on this person is balanced. So the floor is pushing up and gravity is pushing down on that person. And that's why we're able to stand like we are. So there's balanced forces and unbalanced forces. So they don't have the same strength. They don't cancel each other out. They actually cause a change. And of course, objects accelerate or go quickly in the direction of the stronger force. So you can see in this tug of war that in this case, the ones on the left are able to pull a lot more. They're having more force than the ones on the right. So it's moving. They're moving 100 newtons to the left where it's 50 to the right. So it's unbalanced. So then that's going to make them go to the left. Okay. If you see here on the slide, the one in the red shirt has that normal force. It's not sliding. The same force is coming from the bottom and the top. But the yellow is on the slide, and the gravity is pushing that person down. So they've got, the stronger amount is going to push them down that slide. Okay. So when forces are balanced, then they stay like they are. And when they're unbalanced, they're going to move. So let's talk about gravity. So things fall to the ground, and gravity acts even when objects don't touch. It pulls objects downward. So we might have seen, y'all are a little too young maybe, but you might have watched some Wile E. Coyote cartoons. A lot of times he has a hard time with gravity. He falls off cliffs, and usually he stands there for a minute before he falls down, which is not what gravity would really do. But it's funny. So the force of gravity is the force with which the Earth, Moon, or other massively large objects attract other objects towards itself. So gravity is the weight of an object. We've talked about that a lot. We've said we can blame our weight on gravity. It's gravity's fault that we have 5 more pounds on us. All objects on Earth experience a force of gravity that's directed downward towards the center of the Earth. So we all feel the gravity here. Now, friction is a force that acts in the opposite direction of the motion, and it slows the object down, okay? So we're going to do a lot of experiments with this week. But if you look in the picture, you can see that there's a force on the left side pushing it. So, of course, the motion is going to go towards the right. But the friction, the floor, is going in the opposite, and so it slows it down. Now, some surfaces have more or less friction. So think about a really, really heavy box. And if you were to try and push that heavy box on your hardwood floor or your tile, it might slide a little easier. And if you put it on carpet, it might be a little bit harder to slide because there's more friction there. Friction can also affect objects that aren't moving, like an object sitting on an incline and not sliding, because different materials provide different amounts of friction, like we were just talking about. So it all depends on what the materials are. You've probably put something on an incline before, and it doesn't slide down, and then sometimes it does slide down. It all depends. So a box slides across ice and wooden floor. Which one will come to a stop first? So let's think about that. And if you've ever walked on or slid on ice or wood floor, you might have a better idea about it. But just think about it. Think about ice, how it feels, how things are on it, and think about the wood floor. Most likely, the ice is going to keep the box moving. The wood floor is going to slow it down just because there's more friction in the wood floor than there is on that ice. Okay, now weight. We have talked about this, and you guys know this. Weight is not the same as mass. Weight is not the same as mass. Mass is the amount of matter something has. And weight is how much gravity an object has on it. And weight is also a force. Okay. So, like we said, how much does a boy weigh with a mass of 55 kilograms? And when and how would his weight change? Your weight can change because of gravity changing. So if that boy was to go on the moon, that would change it. Or somewhere with less gravity. All right, so now we're going to talk about Newton's law of motion. You probably have heard of Sir Isaac Newton. He has several laws that we talk about in science. So today we're going to talk about Newton's law of motion. His first law: an object in motion will stay in motion, and an object at rest will stay at rest unless it's acted on by an unbalanced or another force. Okay? So let's think about that. An object in motion will stay in motion unless it's acted on by another force. So, think about if we had a ball and we rolled it across the floor. It's going to roll for a little while. Maybe it hits a wall and stops. Or maybe it doesn't hit a wall, but just after a while it stops rolling. Now, the reason it stops rolling is because of friction. Whatever is on the ground, whatever it's going across, that unbalanced force is going to cause it to stop. It wouldn't stop unless there was that. Now, an object at rest is going to stay at rest unless it's acted on. So if you have a rock on the ground, it's going to stay a rock sitting on the ground in that spot until something moves it. So it sounds kind of wordy. An object in motion will stay in motion. An object in rest will stay at rest unless acted upon by another force. But it's very simple if you think about it. Things that are moving are going to keep moving until something causes it to stop. Sometimes, it might run into something might grab it, but that is that other force. Sometimes it's just friction that stops it. Maybe nothing gets in the way, but there's enough friction that it slows it down until it eventually stops. And then something at rest, that just means something being still, something not moving, is going to continue to not move until something causes it to move. All right? Sometimes people call Newton's first law the law of inertia. So inertia is the tendency of an object to resist a change in motion. This says, I'm not going anywhere unless something forces me to. I'll keep going until something stops me. So that's pretty much Newton's law. All right. So you can see here in this video, this is a ball on the European Space Station. So the ball is just there until the force that he puts on it causes it to move. So it stayed at rest until something caused it to move. Pretty cool. All right, still Newton's first law. So of course, with an unbalanced force, meaning just like we said, the friction, something's going right and it gets kind of pushed on from the left, maybe carpet or whatever it is that it's on. Balanced force means it's staying right there. An object at rest is going to stay at rest. Okay? So you can see this here. That soccer ball is at rest. It's being acted on by another force, someone kicking it. Now, once it's kicked, this object's going to stay in motion until it's acted on by an unbalanced force. You've got the wind, you've got the net. There's a lot of forces coming at the ball from the opposite direction, which eventually does cause it to stop. Okay? So, think about this. When you are driving and you brake suddenly, what happens to your body? So think about it. You're just driving along and then you hit the brakes. Your parents hit the brakes. The bus driver hits the brakes. Your body usually moves which way? Forward. We can probably all do it right now, as we hit the brakes. Okay? And that's because there's been a different force acted on. Or when you're speeding up. Or when you turn left really sharp. Okay, think about how your body reacts to those. Okay, now we're going to talk about Newton's second law. This law describes the relationship between force, acceleration, and mass. Okay, so force, is like what you're putting that push or the pull on something. Okay, so which would you have to apply more force to in order to slide it? A box of 30 pounds of books or a box of 60 pounds of books? Remember, LBS is abbreviation for pounds, even though L or B are not in the word pounds. Okay, so you're going to have to apply more force to the heavier box of textbooks. This says which would slide a further distance if you pushed with the same amount of force. So if you are able to have the same amount of force on an object, that means you're pushing it with the same force, the same amount. Which one's going to go farther? Well, the lighter one would move farther, right? The one with less mass. Because it's easier. You think about a little baby kitten and you think about a big lion. If you were to throw both of those up in the air, you'd probably be able to do it a little bit better with a baby kitten. Okay. So, more mass causes less acceleration. We are not going to be able to go as far if it has more mass. And then more force causes more acceleration. The harder you push something, the farther it's going to go, the faster it's going to go. Okay? In official terms, The more mass an object has, the greater force required to change its motion. Heavier objects are harder to move than light ones, right? It's really not too tricky of a concept to understand. Sometimes we let the words get to us, but the more mass, the more matter inside of something like this elephant, you've got to try a little harder to get it to move. In this picture, you see the two guys in their rocks. Blonde-haired guy is going to have a rough time compared to brown-haired guy. Okay. So the greater the force, the greater the acceleration, right? Here's our equal sized balls. If I push, you can see my force is bigger. This arrow is bigger than this one. So I have a bigger arrow. This is bigger force on that ball. Look how much farther it went. Because the harder I push, the farther it'll go, which is also, you know, not a hard concept to put in our mind. So if you apply more force, it has more acceleration, and it accelerates at a higher rate. Makes sense. Now we have Newton's third law. So there's just three. Forces always exist in pairs. If you've been in my classroom, you've seen one of these. If you get mad and punch the wall, you are applying force. And why does that hurt your hand? The same reason why when y'all touch this and it clicks onto here, what happens? This one comes up and clicks back over here. Okay, because you can't just punch that wall without a force coming back at you. Whenever one object exerts a force on a second object, the second exerts an equal and opposite force. So when you punch that wall, your hand supplied that action force, but the wall returned it. And that is why it hurt. Okay? You didn't punch through that wall. It gave that equal and opposite reaction. All right? So if you were to put your finger and try to push it on the wall, you feel it kind of resisting that. Okay? Whoops. I was trying to zoom it in. I don't think I can do that. So the balloon, it contracts the air outward, and the reaction is the balloon moves in the opposite. Have you ever let a balloon go and it goes this way and the air's moving that way? Okay? So your swimmer down here, the swimmer pushes the water in a backward, but then that causes you to go forward. This book just sitting here, the table and the weight of the book. Okay? So, again, the third law, whenever one object exerts a force, the second one exerts an equal and opposite force. So you're going to still have, it's going to have those equal reactions. All right? So that is the big picture of what we're talking about over the next few weeks with force and motion.